Hey guys, welcome back. In this video, I'm going to show you guys how to create a simple neural network, a perceptron network, which is a network with no hidden layers, with my new library, NeuNet. This is going to be an interesting video, so let's jump right. Okay, so before we actually start creating our perceptron network, we have to install it, right? So here's my PyPy page. For those guys who don't know what PyPy is, it's just the Python packaging index. So you just want to go to this page, and it kind of gives us a description on how to use my network or my packet, sorry. But I will be explaining all of this, so you guys do not need to worry about that. The only thing that we need to look at this page is just the pip install NeuNet. And also, by the way, before we even start this video, if you have any questions or any problems with this library, like maybe you type something wrong and it's giving you an error, what you could do is you could just go to the project description, and if you just scroll down, you can see that you can email me right here. Just click here, and then you could just email me. Let's actually get started. So what you want to do is you just want to click that copy and paste button. Now you can just copy and paste it. So you just want to say pip install NeuNet. Let's click enter or hit enter, and it should install a library for us. Alright, so the first thing we need to do is import. So this is actually only going to take 5 simple steps. So we need to import my library. So how we do that is we say from NeuNet, make sure the ends are capital, import all, just like this. Okay? The next thing we need to do is we need to actually initialize our network. So we say net is equal to network. Just like that. No clue what this is there. Network. Okay. And if you don't have any errors, you're great. Obviously, you could change this variable to whatever you'd like. Next thing we need to do is we need to actually initialize our training data. So now we'll take the time to talk about what our network is and how it works. Okay. So basically, this network is going to take any amount of it'll take any amount of inputs. Okay. So for example, we'll say 0, 0, 0. Gives us an output of 0. Okay. And then we say that 0, 1, 0 gives us an output of 0. Okay, then we say 0, 1, 1 gives us an output of 1. All right, so we can give any amount of inputs and outputs. Okay, so actually one output for any amount of inputs. Okay, so if you'd like to figure out how we get our outputs from these inputs, you can just take a moment to check that. But basically, the pattern I just used was I just took this last digit and I just made that the output. All right, so basically what's happening is we just feed this to our network. So we're giving it these inputs is equal to this output, and it tries to find your algorithm. It tries to find your pattern. So then when you give it only 3 digits, it has to find our output. So let's say we give it 1, 0, 1, right? Now it has to find our output. In this case, it's 1. Okay, so that's what we're going to be solving. Version 3 is going to come out like a few hours after this video. That'll allow us to actually label these items so we can have a more user-friendly output. But right now, if it's really close to 0, then we know it's 0. And if it's really close to 1, then we know it's 1. So by the way, it can never be 0 or 1. In any neural network, the output can be 0.999999, but it can never be 1. Or it could be 0.000001. It's never just gonna be 0.0 end. So yeah, so that's that. And let's actually put this in our code right now. So what we want to do is we want to define our inputs first. So we can say training inputs, and then let's make an array with all these inputs. So we can say numpy.array and create an array here. So let's just put whatever we just put. So we could say 0, 0, 0, comma, and then 0, 1, 0, comma, 0, 1, 1, and then comma, we'll say 1, 1. Alright, so now let's define our outputs for these. So you could say training outputs, right, equals numpy.array. And then inside here, we just want to put our outputs. So for 0, 0, 0, it's going to be 0. For 0, 1, 0, it's going to be 0. For 0, 1, 1, it's going to be 1. And then for 1, 1, 1, it's going to be 1, 2. Okay, so we define these. And now this is it for our training data. So now we can move on to training our network. By the way, if you guys haven't, or if you guys or have any errors with the syntax code, you could just actually see the code right here in my project description. So if you'd like, you just copy and paste this there so you don't have any syntax errors. But yeah. So now let's actually train this. So we have 3 parameters. So we have net.train we want to set. Inside here, we want to pass our training inputs, our training outputs, and then the iterations that you want it to train for. So say training inputs, training outputs, and then we just want to put our iteration. So you don't want to make it too high, but you also don't make it too low, because if it's too low, then it won't have great accuracy. If it's too high, it'll take a very, very long time. So I'd say a good number is about 1,000. Okay. Now, finally, what we want to do is we want to run this. So we can just say run here, and then we just want to say net.train, or sorry, net.run. And now in here, we want to put our new 3-digit array, and we're not going to give the output. Okay, so let's just make it simple and put it in here. So we'll say column is equal to np.array, and we'll create our array. So, and now let's just give it, I don't know, is 101. Did we use that yet? No, we didn't. Okay, so we can say 101, and we won't count the output. So we'll just run with this column here, and we'll see what it gives us. Yeah, so that's it for our code, by the way. We have just 5 simple steps: 1, 2, 3, 4, and then 5, because I'll include these 2 as a step. Obviously, what you could do, you could just put this in here. So just like that. But I'm just going to do it like this so you can see it better. Okay, so now let's run this and see what happens. Alright, so it's taking some time. Obviously, it has to pass through all these iterations. Yeah, 1,000 iterations. Oh wait, no, actually, what am I saying? We haven't printed this out yet, so it's actually solved already. But we haven't done anything with the output. Sorry, guys. So then finally, we just have to print this. So we just say print. We'll say this run equals, and then we'll just print run. Actually, you know what? Let's just put this all in one line. So we'll say print, and then just make it like this. All right. So now this will give us an output. Sorry about that. All right, so okay, so now we get this output 0.49. So 49 to okay, so I guess it hasn't found our pattern yet. It's, you know, it's got an output, but it hasn't really said we wanted 1. Now why? This is because we need more data here, right? We don't have enough. We have 4 pieces. It can't really learn, but you can see it actually successfully solves through everything, and it's worked. So all right, guys, so that's it for this video, guys. I hope you guys enjoyed. If you guys did, please hit that thumbs up button and subscribe to the channel. If you'd like to see more videos like this, you can just put down in the comments below. But anyways, yeah, that's it for this video. Some more videos I'd recommend to check out is probably my neural network videos, where I kind of talk about different packages like TensorFlow and Brain.js, so you could build up on your neural network knowledge base. I will also be teaching you guys. I'll make a video like a week from now, talking about how to create your own neural network from scratch. So all the math. So kind of how to publish your own library, like I did, like a neural network library. But yeah, so once again, that's it for this video, guys. I hope you guys enjoyed. Peace.